Hi all, my name is Catherine, Assistant Professor from the Department of AAML, SNS College of Technology, Coimbatore. Today in our lecture series, we shall see about the stream cipher. So earlier we have seen what is a block cipher and what are the algorithms being used in the block cipher. For example, we used DES algorithm, double DES algorithm, and triple DES algorithm under the block cipher. So today we shall see what is a stream cipher and what are the algorithms can be used under stream cipher. So stream cipher is, as the name suggests, stream cipher takes input as bits instead of taking it as blocks. So here you could see the plain text which is about to be encrypted is taken as stream of bits. So what happens here is there is a key. In order to encrypt a message, you always need a key. So here the key is not being directly given to the plain text. Instead, it goes under a key generator. So why we do this is to make it more secure. So instead of directly using the key to encrypt a message, the key first goes to the key generator. So this key generator produces a stream of key in order to be encrypted along with the plain text. So here in stream cipher, the normal encryption we always do is the XOR operation. So encryption is simple, but the generation of the key is a complex one here, making this algorithm more secure. So what happens in the receiving side, the receiver receives the cipher text. So the receiver will also have the access to the key and the same key generator, whichever is being used in the encryption side. So what the receiver does is he sends the key to the key generator and he gets a stream of key. So with the help of that key, he decrypts the message and the plain text is being received on the other side. This is the general scenario of what happens under the stream cipher. Now let us see an algorithm which uses this stream cipher concept. So basically the output of the generator is combined one byte at a time with the plain text stream using the bitwise XOR operation. As I told you earlier, here the encryption and the decryption makes use of the XOR operation. So under this stream cipher, we have an algorithm called RC4 algorithm, which was designed in 1987 by Ron Rivest. It uses an array state vector S of length 256 and it uses a key array of length 256. Here the key is encoded with ASCII characters. So we have three main steps in the RC4 algorithm: the key scheduling, key stream generator, encryption and decryption. So let us see one by one. So under this key scheduling algorithm, we have certain steps. So here the first step is the number of iterations. So the algorithm takes the iteration according to the size of the S array, and a temporary vector T is also created here. So if the length of the key is 256 bytes, then key is transferred directly to the temporary array T, or else the key is being repeated. I'll show you with an example. So here the algorithm goes like this: the initial permutation of S array. First, you initialize j is equal to 0 and you create a for loop I is equal to 0 to 255 since the size is 256 bits. So now we are going to calculate j such that j plus s of I plus T of I mod 256. Here S of I is the state vector. So next you are going to swap S of I comma S of j. So T of I is equal to key array. Let us see with an example. For example, if you are taking an S array of size 8 bits, so 0 to 7 you are going to initialize it as. So the key array is 1236 and the plain text is 1222. So you first you have to initialize the temporary array T. So what I told you earlier is the temporary array, the key bits will be directly transferred to the temporary array. So what do we have in the key array? 1236. So but the size of the S array is what? From 0 to 7. So in order to keep the size of the T array and S array same, you are going to repeat the key array. 1236 is again being repeated. So until this will be repeated until the size of the S array. So next is nothing but the key stream generation. Once the S vector is initialized, the input key will be no longer used. So here the number of iterations equal to the size of the key. So let's see how the stream generation, the main part is the key stream generation here. So initially you are initializing it with I comma j is equal to 0. While it is true, I is equal to I plus 1 mod 256 and j is equal to j plus s of I mod 256. Next, what you have to do is you have to swap s of I comma s of j and t is equal to s of I plus s of j mod 256. So now once you do this, you will get a new key. New key will be generated in this key k array. So that is how the original key what you are sending inside the key stream generation will not always be the same one. So here encryption and decryption, obviously to encrypt you have to XOR the value of k with the next byte of the plain text. To decrypt, obviously you have to do it with the XOR the k value with the next byte of the cipher text. So for example, here you are taking the plain text, whatever you're getting is 1100, some bits of zeros and ones, and you are going to XOR it with the key stream, and obviously you'll be getting the cipher text. So this is how the encryption and the decryption part is simple, because what we are doing is we are just doing an XOR operation, whereas the key scheduling and key stream generation goes under a algorithm which takes a permutation and it does a swapping, and the original array will be the totally changed. The key array, whatever you are giving as input, will not always be the same as the output. So this is all about the key stream generation. I hope you all understood. Thank you.